Assalamualaikum. My name is MOHAMMAD. I'm here with Ashraf, Farhan, and SAFIEE. Together, we will present about MOV, metal oxide varistor. Okay. So, what is metal oxide varistor? A metal oxide varistor is a device used as a component in electrical component. Besides that, a varistor is also known as VDR, which is a voltage dependent resistor, which is also one kind of electronic component. Um, MOV is made of a ceramic mass of zinc oxide grains in a matrix of other metal oxides, such as small amounts of bismuth, cobalt, and manganese, which is sandwiched between two metal plates, which is the electrodes. MOV can be compared to fuse in terms of functionality because fuse cuts over current, but MOV cuts over voltage. The main function of this component is to protect the devices from high transient voltages. These components cannot resist the transient voltage above the exceeded rating. Once these components absorb the transient voltage, then they tend to dissolve it like heat. When this method continues continually for a short time, then the device begins to exhaust because of the extreme heat. These varistors are connected in parallel to supply better energy handling capacities. Metal oxide varistors are also connected in series to supply high voltage ratings. So based on the diagram, as you can see here, when the voltage is increasing, the resistance is decreasing. So this further explains why the MOV will slowly dissolve, will slowly melting because of the high transient voltage.
Okay, thank you for Muhammad RIDZWAN. So now I will explain about metal oxide varistor application. The application of MOV include the following. First, metal oxide varistor are used to protect voltage spike of voltage line to line, arcing and switching. Second, this varistor can be used to protect different kind of device from faults. Third, these are used for single phase line to line, line to ground protection within electrical circuit. Fourth, these are used for protecting the switching device like a transistor, thyristor and MOSFETs. Next, these are used in the circuit to protect from voltage spikes as always as such. 7. In most of the cases, they are used in strap, adapter and other examples. Then these varistors are used in normal electronic device like digital cameras, cell phone and MP3 players. And lastly, for this application, MOVs are used to protect the industrial AC lines, power system, data system and others. Okay, that's all for MOV explanation. Thank you.
Okay, next is about cable sizing. So this is a power input connection. Basically, the power input cable is 5 core 4 mm square. Okay, so the issue and the question that given by our lecturer is can we change the size of incoming cable to 2.5 mm and why? Okay, this is a table that provided by Mega Cable manufacturer. So we refer to 3 or 4 cable in 3-phase AC. The size is 2.5 mm square. Okay, so the limitation of current carrying capacity is 21 amp, while the current that required for the system is 14.4 amp. Okay, so it should be okay if we want to change the size of cable to 2.5 mm square. Okay, that's all. Thank you. Okay, next is about cable sizing. So this is a power input connection. Basically, the power input cable is 5 core 4 mm square. Okay, so the issue and the question that given by our lecturer is, can we change the size of incoming cable to 2.5 mm and why? Okay, this is a table that provided by Mega Cable manufacturer. So we refer to 3 or 4 cable in 3-phase AC. The size is 2.5 mm square. Okay, so the limitation of current carrying capacity is 21 amp, while the current that required for the system is 14.4 amp. Okay, so it should be okay if we want to change the size of cable to 2.5 mm square. Okay, that's all. Thank you.
Assalamualaikum and good day. I'm HASIF. I'm going to explain a little bit about screening. The transformer of the high voltage construction kit can be used for partial discharge measurement. Screening in this context means shielding the entire HV area with conducting material to eliminate any potential interference from the outside of measurement area. And this will ensure that any measurement we do inside the HV testing area are solely from the inside and no interference from the outside. By screening or shielding the area, it will be free. The area will be free from external partial discharge, static discharge, electromagnetic wave, or radio wave. Wall, ceilings, and the floor of the test area have to be covered with a conductive material. And then the erected shield should be grounded perfectly. So any interference from the outside that caught by the screening panel will be grounded and won't interfere with our experiment or measurements. Each individual stripper must be carefully joined to the next one so that the conductivity between the sheet is as high as possible. Two methods of joining the stripper are by welding or soldering, while screw and bolt are not preferable as they will create more resistance and the contact won't be as good as welding and soldering. Typical material for screening testing area are copper walls, copper mesh for walls and ceilings, copper sheets for the floor, copper braided cable or copper waffles. These are the screen measured area. This is the copper mesh and this is the copper braided cables. Thank you.
Now I'm going to continue on the potential measurement of how we measure potential in this kind of transformer. So at the bottom of the transformer, we can find these pins of 1px, 2px, 1pu, and 2pu. These are the series connections of primary windings from 0 and up until 440 volt. And then if you parallel it, or if you take a note in between 2px and 1pu, you can get a parallel connection of the primary winding, and this will tap into 0 to 220 volts. So like the previous one, there are two windings in this transformer, mainly the primary winding and the secondary winding. The primary winding, however, has the potential of series connection and potential of the parallel connection, which in series connection, it can be from 0 up until 400 volts, and for the parallel connection, it can be from 0 until 200 volts. While the secondary potential is in between the lower end of the transformer, and in between that and the top of the transformer. So from that, tapping from SO up until S1, the secondary winding of the potential measurement can be from 0 up until 100 kilovolt. Thank you very much.